For our next video in this little series, we're going to work on regression. So many of you probably remember this from Stats 145. These are used a lot. So we've got a predicted variable and an independent variable, or a dependent and independent variable. So we're going to use days of sun and inches of rain and see if they're predictors of tons of corn per acre. So we have a bunch of samples here, and we're going to see if there's a relationship. So we can highlight two of these. We're going to go to Insert, and this is under Scatter or XY plot. And one thing you want to make sure of is that your Y, your predicted variable, your dependent variable, is on your Y-axis. And your independent variable is on your X-axis. So it looks like we have that because we have a range much higher here than here. So we're going to go ahead and we're going to click on one of these, and we're going to add a trend line. So we're going to add, for our purposes, we're going to add only linear trend lines. There are other uses, but we're not going to worry about those. We're also going to display the equation and the R squared. And there we go. That's it. We've got our first chart done here. We'll zoom in a little bit, and we'll talk about this. So we don't have any humans involved in this. If this is human behavior, an R squared of 0.36 is better. R squareds, again, will range between 0 and 1, 1 being a perfect fit. So there's a lot of other variables that play into this. So again, 36% of the variability in Y in our tons of corn produced per acre is caused by days of sun. So it's not a great predictor. There's 64% there that is not predicted by that. So there's something else going on. But there is some relationship. It's not that there's none. And then this tells us that for each day of sun, we get 1.9 additional tons of corn. So that's what that means. So we start with, we get 200 tons of corn just for being there, and then for each additional day of sun, we have 1.9. So that's one way of doing it. Or excuse me, that's inches of rain. And I'm going to change this so I know this. So we have rain versus tons of corn. Try that again. Rain versus tons of corn. So for each inch of rain, we get an additional 1.9 tons. So then let's do this again, but now we'll do days of sun. And we'll insert. All right. That did not look the way I thought it should. Let's remove this and let's add this. So we've got our X, Control Shift down, and our Y values are here, Control Shift down. All right, and right away visually we can see that this is a lot more consistent. So we would naturally assume that that's going to be a better predictor. So again, we're going to add a trend line. We're going to display the equation and R squared. And label this one. This is going to be sun versus tons of corn. All right, so you can see between the two that sun is a much better predictor because the R squared is much higher. So 93% of the variability is sun. And then 36% of the variability is rain. So you can see that adds up to over 1.0. Don't worry about it for this purpose. Maybe you explore some things like collinearity and some things like that would help this. We would actually use multiple linear regression would be a better model for that, but that's kind of outside the scope of this course. So again, each additional day of sun in this instance is producing 15 more tons of corn. Or excuse me, 16 more tons of corn. Just because the R squared is lower here does not make that number lower. It just happens to be true in this instance. So if a question were something like, how much additional corn would you get for each day of sun? The answer would be 16.566. And sun is a much better predictor than rain. So there you go. There is regression. There's also, I'll show you a couple of things. You can get R squared, your known Y's, known X's. You can get the same number by doing that. But that's enough for now. On to the next video.